Alright, Chapter 5, Bridge Construction Materials. 5.1 General. The concrete is essential components of the material with the adequate strength, with the most structurally the best suited, the relatively mass member of the transmit can provide the load of the directly the foundation material. Although the concrete has low tensile strength with the reinforced with the steel bar of the produced material suitable for the construction of the flexible member of the deck slab of the bridge gird with the essential pre-test concrete that is produced with the technique of the apply of the compression to the concrete by the main over the highly stressed strain of the bear with the high strength of the steel wire with the compressive the strength is sufficient to offset the tensile strength of the couple of the applied loads pre-stressing has greatly increased the maximum span length of the concrete bridge. Physical and mechanical part, the strength of the compressive, the strength of the high, but the shear tensile strength is much lower, but about 12 to 10% of the perspective of the compressive strength of the porosity of the concrete is inherently porous, the permeable since of the cement paste never completely filled with the space between the aggregated particle of the permanent absorption of the water may be caliper in action and passage of the water under the pressure of the extensible. The concrete is considerably extensible with the undergoes large extension without cracking. However, the pursuit presuppose the high quality of construction freedom with the restraint. Fire resistance, high quality concrete, the high resistance of the effect of the fire, with the high with the intent of the heat, with the damage of the concrete. Elasticity of the concrete with the ordinary load, with the elastic with the strength of the proportional with the strain under the sustained load. Elasticity of the concrete significantly lower due to the creep that makes the concrete last likely to crack. Durability. The durability of concrete is affected by the climate exposure of the general as with the water cement. The ratio of the increase of the durability will decrease correspondingly properly proportioned mixed in place. The concrete is very durable. Anti-stressity concrete is itself with generally isotropic, but once reinforced with the steel bars or pre-stressed with steel wires becomes the anti-tropic and strength varies depending on the direction of which it is loaded. 5.3 Indication of classification deterioration. When performing an inspection for the concrete structure, it is important the condition of the drill, but describe the very close the concise for the term, but the can be later understood and otherwise the common term but describe the concrete deterioration. Describe the cracking to the concrete may be described the variety of the way. Some of the more common way to determine the surface of the appearance of the depth of the crack, the width of the cracking, the current state of the activity, the structural nature of the crack, surface appearance of the structure, or the appearance of the crack can give the first indication of the cause of the crack. In two categories exist. Pattern or map craft. These are rather than short craft, usually uniformly distributed and interconnected the run of all directions. Figure 5.1. The cracks are the result of the bruise strength of the contraction of the surface of the area of the possible the increase of the volume of the interior of the concrete. Any other type of the pattern is called a decracking. The cracks usually start on the lower part of the concrete slab adjacent to the joints where the moisture they accumulate with the progress of the wave of the corners of the slab. Vertical cracks near the vertical expansion and the abutments of the walls can be also classified as decracks. Alright, individual cracks. These cracks run with a definite direction. Definite direction. There may be multiple cracks on parallel definite intervals. Individual cracks indicate tension of the direction perpendicular with the cracking. The surface term may be used to describe the direction of the individual isolated with the crack runs diagonal, longitudinal, transverse, vertical, or horizontal. The directions of these cracks are demonstrated in 5.3. Depth of the crack. The category itself is self-explanatory. 4 categories generally used to describe the cracking of the depth of the surface of the shallow, the deep, or the thorough. Width of the crack and the width ranges of you to find generally less than 1/32 of an inch medium. And then this shows the pattern of the map cracking on the pier, and this shows the decracking on the deck, and then this shows the figure 5.3 shows the nomenclature of individual cracks, shows the direction of the travel longitudinal, transverse, diagonal, play of the U with a big bridge deck. Then show the horizontal, vertical evaluation of the pier, nomenclature of individual cracks between 1/32 and 1/16 of an inch wide over the 1/16 of an inch. Current state of activity. The activity of the crack refer to the presence of the factor cover the cracking. The activity must be taken into account when selecting the repair method. The two categories exist. Active crack. The cracks of which where the mechanisms cover the cracking is still at work and the crack is currently moving regardless while the crack is formed initially without the force of the cover the form and are not and still in the work of the must be considered active. Also any of the crack for which act as cover cannot be determined should be considered active. Dormant crack. These cracks are which are not currently moving or from which the movement is such magnitude the repair of the material will not be affected by the movement. Structural nature of the crack. The cracks may be also categorized of the structural cover, the excessive light of the dead load of the non-structural cover. The other means the structural cracks will usually substantial in the width. The opening may tend to increase the result of the continuous load and creep the concrete, but in general it can be difficult to determine the readily during the visual examination of the crack. The structural and the non-structural the determination frequently require the structural engineer. Alright, the combination of the description that describes the cracking accurately will usually necessary for the surface of the term of the various category. For example, there's one shallow, fine, dormant pattern cracking the shallow, wide, dormant, and isolated short crack. The disintegration of the concrete may be defined as the disintegration deterioration of the concrete in small fragments of particles due to any of the causes of the difference of the spalling of the large piece of the intact of the concrete, the law of the spalling of the curves, disintegration, make out the cause of the variety of the causes, including aggressive water attack with freezing, thawing, chemical action, poor construction practices. Two or more commonly used terms are either describe disintegration or scaling and dusting. Scaling. There's gradual, continual loss of the surface of the motor of the aggregated over the area. The inspector should describe the character of the scaling, the approximate area involved with the location of the scaling on the bridge, and the scaling should be classified as follows. A. Light scale, loss surface of the motor up the 1/4 inch of the deep, the most surface of the exposure of the course of the aggregates, the figure 4 of the considered light scale. B. Medium scale, loss surface of the motor of the 1/4 inch to 1/2 inch deep, with some of the added water loss between course aggregated in figure 5.5 is considered a medium scale. Heavy scale, loss of the surface of the motor surrounding the aggregated particle of 1/2 inch to 1 inch deep is considered the heavy scale. The aggregates are clearly exposed and stand out from the concrete, figure 5.6. Severe scale, off the course aggregated particles as well as surface of the material, mortar and mortar surrounding the aggregates are considered severe scale. The depth of the loss exceeds 1 inch. Alright, let's look at the figure 5.4 show the light scale, and then the figure 5.5 show the medium scale. Figure 5.6 shows the heavy scale, and then shows the little core, I guess. Alright, dusting. Dusting of the development of the powdered material with the surface hardened in concrete. The dusting will usually know that the horizontal with the concrete surface with the receive with a great deal of the traffic. Typically, dusting is resolved with the poor construction practices. For example, the sprinkling water of the concrete surface during the finishing of the well with the frequently resulting in dusting. Spalling of the design is developing fragments with the usually shape of the flakes and detach the large mass of the previously known of the spalling of the difference of the disintegration in the material being loft with the mass of the concrete, not individual aggregate the particles that are loft, the binding matrix of the disintegrate. The distinction between these two systems is important. The attempting to relate the system of the concrete problem spalls can be categorized as follows. The small spalls with a not greater than 3/4 of an inch of the depth of the no greater than 6 inches in any dimension. Large spall with a depth of 3/4 inch greater than 6 inches in any dimension. Special cases of spalling. Two special cases of spalling must be noted. Pop-outs. They appear with the shallow typical conceal the depression in the concrete surface. They may be resolved with the freezing of the concrete contained with some of the unsatisfactory aggregated particles. They are easily recognizable by the shape of the pit of the remaining the surface by pushing offending the aggregated particle usually being visible in the holes. Spalling covered by the corrosion of the reinforcement. One of the most frequent causes of the spalling of the corrosion of the reinforcement during the visual examination. Spalling covered the corrosion of the reinforcement usually is an easy system to recognize the sin for the corroded metal will be visible along with the rusting stain of the diagnostic will be straightened forward. Joint spalling with an elongated depression along with the expansion of the contraction of the construction joint. Figure 5.4 shows the cause of the deterioration. Once the inspection of the concrete structure that has been to be completed with the cause of any of the deterioration must be established if many of the systems may be called more than one mechanical activity upon the creating concrete. It is necessary to have an understanding of the basic underlying with the cause of the damage of the deterioration. Figure table 5.1 summary of the various carriers of cause of the deterioration of the concrete. The associated indicators of the are discussed. Accidental loading. The loading are generally short duration. One type of event such as the vehicular impact on the or an earthquake. These loadings shows a large ball, and then shows your figure 5.10 ball due to the reinforcement corrosion. And 5.9 pop-outs can generate strength higher than the strength of the concrete, resulting in localized general failure. With the type of the damage that indicate the spalling of the cracking of the concrete, laboratory analysis is generally not necessary. Chemical reaction of the category include the severe specific cause of the deterioration. They exhibit the wide variety of the system and described. An acid attack of Portland cement is generally not very resistant to the attack of the acids, although weak acids can be tolerated. The product of the combustion many of the fuels contain the sulfuric gases, which combine with the moisture of the form of the sulfuric acid. Alright, figure 5.11 show the joint spall with the figure table ruin relation to the system, the cause of the destructive deterioration of the concrete, and then show the systems. Your external loading would be the cracking, and then your chemical reactions would show the cracking, disintegration, and the seepage, and also the external loading is spalling. Construction errors with the construction fault of the cracking, and also the joint failure, seepage, and spalling. Corrosion would be cracking, and then spalling, designing errors, cracking with a joint failure, seepage, and spalling. Erosion would be disintegration and erosion, and then freezing and thawing would cause cracking, disintegration, and spalling. Settling movement causes the cracking and distortion movement, and the joint failure. And shrinkage would cause your cracking, and would cause cracking. Temperature change, cracking, and joint failures and spalling. Other possible source of the acid formation of the sewage and the sum of the piece flow of the sum of the mountain water stream of the visual examination show the disintegration of the concrete leading to the loft of the summit. Paste aggregated with the mixture with the reinforcing steel, the reach of the acid and rustaining of the cracking spalling of the must maybe see the nature of the solution in which of the deteriorated concrete is located. Unknown laboratory analysis can be used to identify the specific acids involved with the alcohol carbonated rock reaction. Certain aggregate of the carbonated rock having been reacted in the concrete, the result of the reaction that have been both the beneficial and destructive visual examination of the reaction with the shear of the distributed concrete and structure will generate with the show of the map of the pattern crack of the line. The general appearance of the indicator the swelling of the concrete with the reaction with the distinguished from that alkaline silica the reaction with the lack of the silica the gel exudates at cracks. Petrographic examination may be used to confirm the presence of the alkaline carbonated rock reaction. Alkaline silica reaction. The sum of the aggregate with the containing silica with the result of the high-level alkaline solutions may react with the expense of the product which will disrupt the concrete. The reaction is indicated in the map of the pattern cracking and the general appearance of the swelling of the concrete with the petrographic examination may be used to confirm the presence of these reactions. Alright, 4 here, miscellaneous chemical act, concrete with the result of the chemical act varying degree, depending on the existence of the nature of the chemical of the concrete have been subject to the chemical attack, usually show with the surface with the disintegration spawn with the opening of the joint with the crack with therefore many, as well as the swelling of the general disruption of the concrete mass aggregate, the particle being ion protruding for the remaining concrete and sulfate attack with the occurring sulfate, sodium, potassium, calcium, with the magnesium, sometimes found within soil with a solution in the groundwater adjacent to the concrete structure. The reaction that involved with the sulfates result in the increase of the volume of the concrete. The visual inspection will show the map of the pattern cracking as well. If the general disintegration of the concrete with the laboratory analysis can verify the occurrence of the reaction described your concrete construction area. The failure to follow these specify the perceived good practice, the outrage for the carelessness that may be leave the number of conditions that make the group together construction area. The typical, the most of these areas that do not leave directly fail with the deterioration concrete. Instead, they enhance the adverse impact of the other mechanics identified with the chapter. The following are some of the most common in construction area: addition of the water to the concrete. The addition of the water while the delivery truck will be often led to the concrete reducing the strength of the durability. The addition of water when finishing the slab will cause the crazing and the dusting of the concrete surfaces. The improper consolidation of the concrete may result in a variety of defects, most commonly being the plug hole of the honeycomb and the cold joint. These defects make the damage easier than any of the damage causing the mechanism to initiate deterioration of the concrete. Improper curing. Unless the concrete is given the adequate time with the care with the proper humidity with the temperature, it will not develop the characteristics expected that necessary to provide durability. System with the improperly cured with the concrete. It can include the various type of the cracking with the surface disintegration in extreme cases where the poor curing leads to failure to achieve the anticipated the concrete strength and the structural cracking that may occur. Improper location of the reinforced steel. This section refers to the reinforced steel with either the improperly located, not adequately screwed with the proper location. Each of these faults may lead with the two general types of the problems. First, the steel may not function structural as intended, the result of the structural cracking with the failure. The second type of the problem is stemming from improper location with the tied steel with one of the durability. The tendency to seem to be that for steel to end up close to the surface of the close up to the surface of the concrete. As the concrete cover the steel that is produced, it is much easier for the corrosion to begin. Corrosion of the embedded metals. Under most of the circumstances, the Portland settlement of the concrete provided the good protection of the embedded of the reinforcement steel. The protection is generally attributed to the high of the alkalinity of the concrete, and with the steel with a relatively high resistivity, all relatively high electrical resistivity of the concrete. However, the corrosion resistance of it generally be reduced over a long period of time. Carbonation of the steel will begin with the corrosion. De-icing of the sulfate is most common cause of the corrosion. Corrosion of the steel will cause the two of the things to occur. First, the cross-sectional capacity of the reinforcement is reduced into them with the reduced load carrying capacity of the steel. Second, the product of the corrosion expand with the simply occupy the 8 times the volume of the original matter that leads of the cracking and alternate smelling of the concrete with the thorough mild steel. The reinforced damage of the concrete will become evident long before the capacity of the steel reduces enough the active effect of the load carrying capacity. However, before pre-stressing the steel light. Reductions in the section can lead to the catastrophic failure. Visual examination will typically reveal most rough staining of the concrete. The staining it will be followed by cracks produced by the corrosion, usually running straight parallel lines at uniform intervals corresponding with the space of the reinforcement. Deterioration continue with the swelling of the concrete over the reinforced steel will occur with the reinforcing by become visible. Laboratory analysis may be beneficial to determine the chloride contents of the concrete throughout the depth of the procedure. May be with the deterioration. Determine the amount of the concrete to be removed during the rehabilitation project. Design errors are generally result of the inadequate structural design and from the lack of the attention to the relatively minor design to detail. The inadequate structural design. This will cover the cracking of the swelling of the area with which for the subject of the highest stress should be identified as the source of the damage. Location of the damage should be compared with the type of the stress that should be present in the concrete. A detailed structural analysis may be required as if the qualified structural engineer should be consulted if the problem is apparent. Poor design detail. The poor detailing may be the result of the localized concentration of the high strip of the otherwise satisfactory concrete. The following are some of the more design detail problems. Abrupt change in section This may be the cause of the stress of the concentration, but may result in cracking. The typical examples of this include the relatively thin bridge deck, rigidly tied into the massive abutments of the patch of the replacement of the concrete that are not uniform in the plane dimension. The re-entrant corner and opening of these locations are subject to the stress concentration, and the insufficient reinforced cracking may occur. Inadequate drainage. This will cause the pound wadding of the which may result in the excessive loading of the may likely leak of the saturation concrete subject. The freezing thaw cycle will be especially vulnerable to this type of damage. Insufficient traveling and expansion joint with the adequate desired expansion joint may result in the spalling of the cracking, spalling of the concrete adjacent to the joints. Rigid joints between the precast units. Design utilizing the precast elements must be provided the movement of between the adjacent precast elements between the precast elements of the supporting frame of the failure to provide this movement and result in the cracking of the spalling, wear of the abrasion. Wear and abrasion of the traffic abrasion, the impact of the cover, the wear of the bridge deck with the log curve, the parapets of the pair of the damage by scraping the action of the surface, such vehicles as snowplow sweep of the deck wears are also errors on the cracking and revealing a jointed edge. Freezing and thawing. The cycle of freezing and thawing. Critical saturated concrete will cover the deterioration. De-icing chemicals may also accelerate the damage, leading to pitting the scale of the damage for the range of the surface of the scale with extension, the disintegration. Laboratory examination of the concrete core with the damage will often show the series of the crack of the parallel to the surface of the structure. Foundation movement of these movements will cover the shear of the cracking and the structure of the the discussion of the problem that was provided in section 7 of the shaft. The shrinkage of the called the loss of this moisture from the concrete may be divided into two categories of this, which will occur with the setting of the plastic shrinkage. This occur with the after setting of the dry shrinkage. Cracking due to the plastic shrinkage will be seen after the few hours of the concrete placement of the cracks are generally wide with the shell of the isolated rather than pattern. Cracks due to the drying shrinkage are characterized by the fitting and fineness of the absence of any of the indication of the movement. They are usually shallow in a few inches of the depth of the orthogonal or block pattern. Changes. The change of the temperature will cover the corresponding change of the volume of the concrete. The well sufficient restraint with the expansion and contraction of the cracking will occur with the temperature change that will generally result from the heat, the hydration, and the cement and large concrete placements, variations, climate conditions, and fire damage. 5. Assessment of concrete. Assessment the existing reinforced concrete with the bridge is basically associated with the flow, identify the cause of the extent of the observed the suspected deterioration, method of the description of the damage for the concrete, possible the cause of the deterioration will be discovered in paragraph 5.5. This section will provide with the guidance that presumably be able to test the method of determining the cause of the deterioration, quantifying the extent of the range of the available test method, large including in situation on the strength of the time of the actual structure as the well as physical and chemical with petrographic have to use upon sample to remove the structure and loading table 5.2 summary of the basic character of the most widely established test method to be classified according to the feature which may be assessed the more reliable in each case. They overview of some of the more common tests follows. The test method is the proper property owner, the corrosion of the embed of the half cell with the potential residuivity core, you have the cover depth, the carbonation depth, and the chloride penetration. Your ASTM designation C87. Your equipment would be electrical and chemical, electromagnetic, and chemical microscopic. You have a concrete quality durable deterioration. You have the rebound hammer C805 mechanical ultra pulse velocity C597 electronic radiographic radioactive radiometer radiographic permeability hydraulic absorption hydraulic petrographic C856 microscopic sulfate content, the chemical expansion, mechanical air content, C457 microscopic cement type content, C85 and C1084 chemical microscopic core strength. You have the core C42 and C83 mechanical pull-out, C90 mechanical, C900 mechanical pull-off, mechanical break-off, mechanical internal fracture, mechanical penetration resistance, C08, C083, C0803 mechanical integrity of the structural performance, tapping, mechanical pulse echoing, mechanical electronic dynamic response, C215 mechanical electronic thermographic, infrared and strain crack measurement, optical mechanical electronic. Additional reinforcement should be consulted with the prior of the actual use of the step of the core drilling. The core drilling recover the concrete with the laboratory and able to testing of the depth of the method to obtain the information for the condition of the concrete with the mixture within the structure of the half of the chin of the core as drilling expensive the structure should be considered only when sampling with the testing of the interior concrete with the deemed necessary of the core. Samples should be sufficient in number to solve the permit appropriate laboratory examination and testing the comprehensive strength of the static dynamic module of the elastic diameter of the core should not be less than 3 times the nominal maximum side of the aggregated warning should be given them taken an X side with the 2 1/8 of an inch diameter core with the concrete taken into the 6-inch maximum size of the aggregated due to the large aggregated side of these cores will be generally recorded in short broken pieces When drilling of the poor quality concrete with any of the side of the core barrier, the material will generally come out with the rubble when the drill hole coring is not practical or recovery is poor with the viewing system, especially the borehole camera, borehole television, borehole view, or may be used to evaluate the interior concrete conditions. In addition, with the chemical testing may be performed in smaller drill part samples from the structure, thus causing substantial lift of the damage for the produced by coring, but the likelihood of the sample contamination is increased. The precision may be reduced. Laboratory investigation on samples of the concrete have been obtained. Whether the coring or the drilling or the other means, they should be examined. If the qualified laboratory and general examinations will include one or more of the following examinations. Alright, petrographic examination. This type of the examination may include the visual microscopic inspection, the X-ray diffraction analysis, differential thermal analysis, the X-ray emission testing technique for the section analysis. These techniques may be expected to provide information following the aggregate condition pronounced with the comment. Some of the cement aggregated the reaction deterioration of the aggregated particle of the plate, the density of the cement pasting, the homogeneity of the concrete, depth of the extent of the carbonation, the outcome of the distribution of the fracture of the distribution of the voids and prevalence of the combination substance. The chemical analysis of the hardened concrete with the selected portion of the paste of the motor with the aggregated reaction with the product that may be used to estimate the cement of the content of the original water cement, the ratio of the presence of the amount of the chloride, other admixture of the chloride analysis for the most common of these analyses for the even to provide the quantitative the measure of the chloride and contamination and thus the potential for active steel corrosion of the various levels of the concrete deck with a sample of the test are usually taken with a rotary hammer drill. The threshold of the chloride content, the amount of the chloride needed for the initiate of the corrosion, approximately 2 pounds of the chloride content of the per cubic yard of the concrete. Physical and now the following physical of the mechanical test of the primarily performed with the concrete with the density of the compressor, the strength of the modulus elastic, Poisson's rate on the pulse velocity volume change of the potential of the freezing and falling. Non-destructive depth. The purpose of the non-destructive depth is to determine the various properties of the concrete, the strength of the modulus elasticity, the homogeneity, the integrity, as well as the condition of the strain without damage from the structure. Some of the most commonly used tests are discussed as the rebound number. The rebound number is maybe as an estimated the informed quality with the size of the concrete with the rebound number is obtained by the special hammer that consists of the steel mat with the tension spring with a tubular frame with the special for the rebound with the number of the BME relay with the calibration curve with which given indication the suit of the concrete strength with the rebound number the increase of the strength of the concrete, the method of the expense of the alloy with the large number the measure of to be rapidly taken to the large exposed areas of the concrete being mapped within a few hours if the entire of the imprecise depth does not provide a reliable prediction of the strength of the concrete, the measurement that can be effective with the smooth of the concrete, surface of the moisture for the content of the concrete, the type of the course for the aggregated size, shape of the rigidity, specimen of the carbon of the concrete, surface of the penetration, resisting the probe with the test. They also use the quick assessment of the quality uniformity of the concrete. The apparatus must be often used the penetrator of the resistance of the windsor of the probe with the pressure gum, the the 32 caliber blank with a precise quantity of the powder to fire with a high strength of the steel probe into the concrete. With the depth of the penetration of the probe into the concrete can then be relayed to the calibration curve of the concrete. Comprehensive strength, a probe will penetrate with the deeper of the density subsurface, the harder the strength of the concrete. Decrease this should not be considered for the precise measurement of the concrete strength. However, the estimate of the component strength may be also obtained by the probe that properly calibrated. The test does not damage the concrete, leaving a hole about 0.32 inches in the diameter of the depth of the probe that may be covered with a minor crack in some of the surfaces following the minor repair of the exposed the surface of the may be necessary. Ultrasonic velocity. This method is involved with the measuring of the type of the tram and the trouble electronically pulled with the compression wave through the known distance for the concrete. The velocity can be used with the stress as if the general condition of the quality of the concrete to assess the extent of the severity of the concrete cracks in the concrete to delineate the area of the deteriorated poor quality of the concrete. Good quality continuous concrete will normally produce high velocity accompanied with the good signal strength. Of the poor quality deteriorated concrete will usually decrease the velocity signal strength of the concrete with the otherwise high good quality, but containing cracks may be produced at higher or low velocity depending upon the nature and the number of the cracks, but will almost diminish signal strength. This method does not provide precise estimate of the concrete strength. The moisture variation in the presence of the reinforcement steel can affect the result. The skilled personnel required for the analysis of the result. Alright, for surface tapping, chain drag. The experience has shown that the human error with the conjunction with the surface of the tapping most efficiently economic the method determine the nature of the delamination of the bridge jack. The chain dragging is most of the commonly used method for this purpose. This is however the various subjects have in the operation must be able to differentiate between the sound and the unsound regions. The result cannot be easily quantified. Steel corrosion assessment. The most commonly used the test assessment of the current state of the reinforcement steel corrosion, the half cell with the potential for the test involved the measurement of electrical potential for the embedded reinforcement bar relative to the reinforcement half cell plate on the concrete surface. The potential difference is more than negative than 0.35 volts indicate the higher degree of probability of action of the corrosion than reinforcement steel. The potential reading of the 0.2 volt lower indicate probability of no corrosion, while the reading of the between 0.20 volts and 0.35 volts indicate the possibility of the active corrosion. Alright, your load test. Occasionally, it may be necessary to examine the overall behavior of the entire bridge structural section of the bridge. This may be the issue for the external measurement of the response dynamic loading aid with the appropriate position accumulators, alternatively monitoring the performance under stack load. Testing load is the most common method, however, is measured for the strain of the deflection with the price leveling of the laser with the stack full-scale test load. These tests are generally expensive but yield the valuable information for the overall health of the structure. This type of the test can be conducted on any type of the bridge, regardless of the material type. Alright, Section 2, Structural Steel.